Hello friends, in this video we are going to see Java exception. In this part 2 of the video we are going to look at multiple catch blocks for a single try block. So when we are talking about a multiple catch block, we are going to look at the ordering those blocks. A try block should have at least one catch block. We already saw this in the previous video. When there is a try block, and there will be one accompanying catch block, and in that catch block we will handle the exception. Try block will throw the exception. Sometimes one can have multiple catch blocks for a single try block. Previously we saw how a developer decides how many number of statements they can keep in a try block. So when there are many number of statements, that particular try block can throw more than one exception type. So in that case we will end up with multiple catch blocks. So in the picture beside we have 3 code snippets. So we have 3 snippets, snippet 1, snippet 2 and snippet 3. So let us assume that these code snippets are logically grouped. That means each snippet will do some task. Let us also assume code snippet 2 depends on code snippet 1 and code snippet 3 depends on code snippet 2. So we kept it in a single try block. So what we try to mean here is when code snippet 2 fails by throwing some exception, executing code snippet 2 is meaningless. The same goes for snippet 3. So since snippet 3 depends on snippets 2, if snippet 2 throws some exception, executing snippet 3 is not useful. So that's why we kept snippet 1, snippet 2 and snippet 3 in a single try block. So now since snippet 1, snippet 2, snippet 3 are dependent on each other, so it is in a single try block. Now let us say each snippet has possibility of raising a different type of exception. So here if you look at the picture, snippet 1 raises an exception of type A, snippet 2 raises a different exception of type B, and snippet 3 raises exception of type C. So we already told that we cannot have separate try block for snippet 1, snippet 2 and snippet 3 because they are dependent on each other. So they are not independent. So if they are independent, we may be having a 3 different try block. Since they are dependent on each other, we kept everything together in a single try block. So in the previous video we already saw that if an exception is caught, if an exception is raised in code snippet 1, then the code flow moves to catch block, not executing snippet 2 and snippet 3. So this is the reason why we kept all snippet in one single try block. But the fact here is these snippets can raise different type of exception. So now we will end up with having multiple catch blocks. If you see here, we have a separate catch block. So the catch block 1 will handle the exception of type A, catch block 2 will handle the exception of B, and catch block 3 handles the exception of type C. So now we have an idea of how we will end up writing a multiple catch block. So the rule goes like this: snippet 1, snippet 2, snippet 3 are dependent on each other. We cannot separate it. So when snippet 1 fails, we don't want to execute snippet 2 and snippet 3. That's why we kept all three snippets together. When we write multiple catch blocks, the order of catch block becomes important. So here we are seeing three catch block: exception A, one for exception A, and another two for exception B and C. Now the question of in which order I have to place these exception blocks comes into picture. So is it okay if I place exception B first, exception C next, and exception A last? So there will be multiple different possible order we can make with these three exceptions. So now the order is important, so we cannot keep the exception in different order in all the cases. Sometimes it is possible, sometimes it will not be possible. So let us explore when ordering is important. When there are multiple catch blocks, we have to place more specific exceptions in the top, then more generalized exception in the bottom. So here the inheritance tree comes into picture. So more generalized exception in the bottom means the very base class of the exception should stay in the bottom of the catch block. So more specific exception will be in the top of the exception block. Let us say exception M and N are two unrelated exceptions. This means they doesn't follow under any inheritance relation, or simply M and N are not in an inheritance relation. But we know that all the exception classes are derived from the base exception. So here exception M will have a base class of exception, and exception N also will have the same base class of that exception. Or in other words, exception M and N are derived from exception, but M and N are not related to each other because they don't have any inheritance relation. So we will have this assumption first. Now we will consider three more classes, A, B and C. But we will assume there is an inheritance relation between these three exception classes. So here if you see, exception C is derived from exception B, and exception B extends exception A. So this is the relation. So totally, let us say we have 5 exception classes. So in this case, and if we assume that our try block is throwing all these 5 exceptions, then we will be having 5 blocks of catch. That means 5 catch blocks, and each catch block is handling one exception type. In this multiple exception blocks, we can place M and N wherever we want. That means ordering is not important for M and N. So M and N are independent class. There is no relation between M and N, and it doesn't involve in the existing exception A-B-C relation. Once again, M and N are independent classes. So that doesn't have any relation with the 5 classes whatever you are seeing here. M is not in relation with N and in relation with A, B, C. Same goes for N. N is in not relation with M and the classes A, B and C. Because of inheritance relation, the ordering of ABC becomes important. So here the most specialized class is C and most generalized class is A. So in the catch block, C should be placed before the catch block of B, and A should be the last class, the last exception block. So it should come after C and B. As already told, M and N doesn't no need to have any ordering. It can be placed anywhere. Now beside is the catch block, and you can see how the catch blocks are stacked up. Here if you see, the ordering of CBA is important because of this inheritance relation and the rule. Most specialized exception should go first and most generalized exception will go last. So according to this inheritance relation, C is coming first, then B, then A. Since M and N are not in the inheritance relation, it can be placed anywhere. So here it is placed together and at the end of the catch blocks, but we can shuffle it anywhere. But CBA should be in a order. Alright, let us see this in Eclipse. So here is the example. In let me rearrange these snippets to this one will be 3 and here it will be 4, then 5. So in code snippet 1, first we are declaring a string. Then there is an array. After that we declared 2 variable and we initialized it. A is holding a value of 10 and B is holding a value of 0. Then inside the try block we have 3 different code snippet, 02, 03, 04 and 05. So you can now imagine snippet 2 is doing a different task. In real world it will not be like this. Here for demo purpose we kept some statement so that it will throw exception. In real world the code snippet 2 sample 02 will be doing some task and snippet 3 sample 03 will be doing some other task. But this task depends on the previous task that is defined in snippet sample 02. So just like what we saw in the PowerPoint deck, the 3 snippet we will assume dependent on each other. Here sample 03 is dependent on sample 02, sample 04 is dependent on sample 03. First we will assume that, but here actually it is not dependent, but let us assume like that. But in real world you will see a code block depending on the previous code block. Alright, so since these 3 are dependent on each other, we placed sample 02, sample 03 and sample 04 inside the try block. Why? Because when an exception is thrown here, since these are all dependent tasks, we don't want to execute this line. That's why all three statements, all three code snippets are placed inside a single try block. Now, if you look at str1, it has some backoff character, but here at a snippet 2, we are trying to access a character at index location 100. But our string str1 doesn't have 100 character, so it will have 5 plus 6 and 1 here, so definitely less than 100 character. So this will throw an exception, and that exception is string index out of bound exception. Next, here we are accessing an array element by specifying the index 15. But here our index will be up to 9. Why? Because index starts from 0. So even though you see an array of integer up to 10, the last element 10 can be accessed with the index 9. But here at sample 03, we are trying to access an element at index location 15. So this will throw an exception called index out of bound exception. Next, finally, we have a division a divided by b. So 10 divided by 0, and this will cause an arithmetic exception. Alright, now let us look at the relationship between these exceptions. So first I am highlighting okay. Exception is the base class for all these three exceptions. So that's why, since it is more generalized class, it is coming in the bottom of the catch block, and you can see there are multiple catch block here. This is the try, and sample 5, this code snippet 5 is having 4 different catch block. So first let us look at the arithmetic exception. I'm going to type hierarchy, and if you see, arithmetic exception is derived from exception. So arithmetic exception is coming on top of this exception class. Now we will look at index out of bound exception. And if you see, index out of bound exception is the base class for string index out of bound exception. So here, that's why we placed a string index out of bound exception on top of index out of bound exception. Why? Because string index out of bound exception is more specific exception compared to index out of bound exception. So that is going on top of index out of bound exception. This arithmetic exception, if you see, it is not in relation with index out of bound exception as well as string index out of bound exception. So we can place this anywhere. That means we can place it on top of index out of bound exception, or in between index out of bound, or in between these two exceptions. So we can place this here, or we can even place that in between these two. So for now, let me keep it here. Alright, now we will execute this code. After that, we will change this order and we will see what is the impact. So first I am placing the code here on the very first line. breakpoint on that line. So now we are executing this, and we know that this will throw string index out of bound exception. So it found a correct match and it is executing that. Now we are saying the string accessed is sample string. This code actually developer keeps to give additional information to the user. Then here we are placing a code that will make a call to the string index out of bound exception. So together this is giving information related to that exception. So it is saying that the string you are trying to access is a sample string, and in string index out of range, and the index is 100. So that's what the get message is giving us, 100. The get message is giving this full message, string index out of range 100. That's what it is giving, and this is our customized message. Now we will comment this piece of code. We will stop executing it and we will comment this piece of code. So now if I execute, let me keep a breakpoint here so that it will be easy. Here we will land into index out of bound exception, because this will throw index out of bound exception, and since it is more specific exception, it will not land there and it will come to index out of bound exception, and we will print relevant message. So here our customized message is the array length is 10, then index referred is 15. This 15 is coming from the exception object itself. So from a list out of bound exception we are calling the get message. Okay, now we will look at the last piece of code. We will comment this as well. This time we will land into arithmetic exception. So everything is working fine if we respect the order of this catch block. Now we will break it and we will study what happens. So let me remove this comment, then I will remove this comment as well. Now what I'm going to do, I am going to shuffle this. Let me place so here, since a string index out of bound and index out of bound exception, since these two are in relation, if you see, you are getting a compiler error, and the error states that unreachable catch block for string index out of bounds exception. It is already handled by the catch block index out of bound exception. So what it is saying, this will throw string index out of bound exception, but since index out of bound exception is in the inheritance tree, it can handle that exception. But since you placed a string index out of bound exception also, this catch block will never reach. So that's what the message is stating here. And if I go to Java perspective, in the problem tab, we can see that error message. So why it is saying that string index out of bound exception will never get reached. So it's already stated that it is already handled by the catch block index out of bound. So how index out of bound exception handles the exception string index out of bound, which is raised by this string operation here. Since string index out of bound is derived from index out of bound, what happens, even though the exception raised is an instance of string index out of bound exception, since the very first block is a base class, when Java compares that, it knows that this particular exception can be handled by this one. So to avoid this error, we can remove this and the error will go away. But here if you see the customized code, what we are keeping is for array, this line. This line anyhow it won't fail, it will put a more generalized message. This will give a more generalized information, but this information may go wrong. So when we throw an exception from a string, our customized code is providing information based on array length. So this information is wrong when a string index out of bound. This information actually is wrong when a string index out of bound exception appears. Alright, now we will place that code back here. Since arithmetic exception is not related to these two exceptions, so if I place that anywhere here, the Java will accept it. So if I save it, I won't see any error. I can even place it in the top. I'm saving it, and if you see, there is no error. Here also you can see. But the moment if I place it below the exception class, we will get an error stating that this will become a non-reachable code. Or because exception will handle. If I go to type hierarchy, here is the arithmetic exception, but exception is a base class for arithmetic exception. So runtime exception and exception. So we can still say exception is the base in the inheritance hierarchy. So it's not immediate base class, but a more generalized class for this arithmetic exception in the inheritance hierarchy tree, tree. So that's why we are not able to place this arithmetic exception. Now everything is okay. So if you see how Java compiler verifies this ordering and make you to keep this exception in a correct order. So that's all in this video. Thank you for watching, and if you like the channel, subscribe it. Bye.